Testosterone. We hear that word and we immediately think aggression. We've all got this picture in our heads of what it means. But what if that picture, the one that's so deeply ingrained in our culture, is missing a giant piece of the puzzle? Well, today, we're going to dive into the surprisingly complicated world of our hormones to find an unlikely suspect behind aggression.
And look, this idea isn't some fringe theory. It is everywhere. I mean, just take this quote from James Cameron. Yeah, the guy who directed some of the most action-packed films ever. He described his younger self as testosterone poisoned. That word choice, poisoned, that tells you everything you need to know about how we culturally see this hormone. We see it as a toxin, something that has to be purged if we want a more peaceful society.
But of course, reality is almost always way more complicated. This simple little equation of testosterone equals aggression, it just feels a little too neat, doesn't it? And that begs the question, is testosterone really the only actor on this stage?
To answer that, we've got to look beyond the usual suspect. We need to consider a potential partner in crime, one that's been hiding in plain sight this whole time, usually praised for the exact opposite effects.
Okay, so here's the classic setup we're all taught in school, right? On one side, you've got testosterone, the male hormone. It gets blamed for everything from bar fights to Wall Street meltdowns. And on the other side, you've got estrogen, the female hormone, which we connect to nurturing, caring, all that good stuff. A really simple, clean binary.
But this is where the script gets completely flipped on its head. The research we're digging into today makes a pretty bold claim. Aggression might be just as much a product of estrogen as it is of testosterone. So how on earth could the so-called nurturing hormone be linked to violence? To see how this works, we need to look at some fascinating and kind of wild evidence. The author of our source points to a study from the journal Hormones and Behavior that they memorably nicknamed the incel monkey study.
So the experiment was actually beautiful in how simple it was. Researchers took a group of male macaque monkeys, and for 15 months, they split them into 3 groups. The control group, they just ate a normal diet. The other 2 groups ate diets loaded with soy isoflavones. These are plant compounds that actually mimic estrogen in the body. One group got a low dose, the other got a high dose. So the only real variable here was how many of these estrogen-like compounds they were getting.
And the results? Whoa, they were staggering. The high soy group, the ones getting the most estrogen exposure, became almost 70% more aggressive. But here's the twist. At the exact same time, their social contact with other monkeys just plummeted by pretty much the same amount. They got more aggressive, but they also became way less social.
And if you think that's weird, get this. That same group also showed a 203% increase in submissive behavior. I mean, how can that be? They became more likely to lash out aggressively and more likely to cower and submit. It's this really confusing, contradictory mix of behaviors.
Now add in this last piece of data, a 30% increase in time spent alone, and you start to see why the source's author gave them that very specific nickname. More aggressive, more submissive, less social, and more isolated. It's a very dysfunctional behavioral cocktail.
Now, the author of our source material offers a personal speculation on what this all means. And to be really precise about it, I'm just going to quote it directly. It says, "To my rightward-looking eye, they might be the kinds of sneaky, bitchy aggression we see demonstrated by male leftists, the kind of skinny punks who hit you with a bike lock when you've got your back turned." This is presented as the author's own take and something they suggest for more research.
Okay, so how does this work on a chemical level? Because this isn't just about monkeys and soy. There's a well-understood biochemical link that actually explains these surprising effects, and it's happening inside our own bodies right now.
The key is a process called aromatization. Inside your body, there's an enzyme called aromatase, and it has one specific job. When there's too much testosterone floating around, it converts that testosterone into estrogen. That's right, the male hormone is a direct precursor to the female hormone in the body. This is a crucial link.
So the crucial point comes from this classic experiment. First, you castrate a male animal. Its aggression disappears. No surprise there. Second, you give it a shot of testosterone, and boom, the aggression comes roaring back. Still makes sense. But here is the kicker. If you give it that same testosterone shot, but you also block the aromatization process, so you stop that testosterone from turning into estrogen, nothing happens. The aggression doesn't come back. This suggests that estrogen is the final key that unlocks testosterone-fueled aggression.
And the evidence doesn't just stop with that one experiment. There is a ton of other research that backs this up. For example, studies show that removing ovaries in females can also reduce aggression. kind of like castration in males. In other animal studies, estrogen boosted aggression, but only under stressful conditions, like those that mimic winter. And even in us, in humans, meta-studies have found a link between estrogen and aggression, especially in men, and it all seems to point to this hormone's action on a key part of the brain called the hypothalamus.
So when we put all these pieces together, the cultural myths, the monkey study, the biochemical pathways, a new and much more complex picture of our hormonal reality starts to come into focus.
The main takeaway from all this source material is pretty simple. Blaming testosterone for everything we don't like about masculinity is just, well, it's too simple. Our hormones don't work in isolation. They are part of this incredibly complex, interconnected system where testosterone and estrogen are deeply intertwined, and both play a role in shaping our behavior, including aggression.
The author of our source material really sums it up perfectly, capturing this central paradox. They write, "We are our hormones both more and less than we'd like to believe. We can't escape our biology, but our biology is not a simple on-off switch for good or bad behavior. It is a very delicate, very complicated dance."
And that leaves us with a final thought to ponder. If our understanding of something as fundamental as our hormones is this flawed, what other simple truths about ourselves might be due for a more complicated and, frankly, a more interesting explanation?